Writing ionic formula. In this video you are going to learn how to write balanced ionic formula, and I'm going to teach you two methods, one being the crossover and one being actually how to balance out charges. So a bit of revision to start off with. This is taken from the periodic table. The symbol here is sodium and this is the atomic number here, 11. The atomic number means the number of protons. It's equal to the number of protons and is this number that identifies sodium as sodium. Sodium will always have 11 protons. That number will not change, and if it does, it becomes a different atom. This, in a neutral or uncharged atom, the number of protons will always equal the number of electrons. So we've got 11 protons, 11 electrons, we've got a plus 11 charge. Protons have a positive charge. A minus 11 charge, 11 electrons would have 11 negative charge, so there's 0 overall charge. So it's a neutral, uncharged atom. So let's have a look at the sodium atom. We've got 11 protons and we've got 12 neutrons. We've got 2 electrons in the first shell, 8 electrons in the next shell, and 1 electron in the third shell there. So there's the third shell, 1 electron, and we've got a total of 11 electrons. And this is what we should have according to the periodic table and the atomic number in a neutral atom. Electron configuration of 2, 8 and 1. So it's got 11 protons, 11 electrons, so overall charge of 0. Every atom's dream in life is to get a full outer shell. So to get a full outer shell, sodium has got two choices. It can either lose 1 electron or gain 7 electrons. It will always do the easiest thing, which in this case is going to be to lose 1 electron. So this electron here is going to disappear and we'll have a new electron configuration of 2, 8. So the first shell has 2 electrons, the second shell has 8 electrons to give us a total of 10 electrons. So we've got 11 protons, that doesn't change. 10 electrons, remember electrons have a negative charge, so we've now got an overall charge of +1. So this sodium atom is no longer an atom, it becomes a sodium ion with a 1+ charge. Remember, you don't need to put the 1 in here, you can. This indicates a 1+ charge. Have a look at one more, sulfur atom. We've got 16 protons and 16 neutrons. And I've worked out the neutrons by subtracting the mass number or the atomic number from the mass number. You'll have to look at one of my other videos to explain that. So we've got first 2 electrons on the first shell and we've got 8 electrons on the next shell, and on the last shell we've got a total of 6 electrons, which gives us 16 electrons, which matches our 16 protons in a neutral atom. So an electron configuration of 2, 8 and 6. 16 protons, 16 electrons. They balance each other out, so we have a 0 overall charge. To get a full outer shell, sulfur will either lose 6 electrons or gain 2 electrons. And remember, it's always going to do the easiest thing, which in this case is to gain 2 electrons. That will get a full outer shell of 8, and here come our electrons in now. So our electron configuration is now 2, 8, 8. So we've got a total of 18 electrons. That gives us 16 protons, that doesn't change, 18 electrons, which gives us now an overall charge plus 16 minus 18 of -2. So the sulfur atom is no longer an atom, it's now a sulfur ion. Remember the word ion, ion means a charged atom. So we put a little 2 up the top and a 2 minus to indicate it has an overall charge of -2, which means it's gained 2 electrons, each of which has a negative charge. So let's see what happens when sodium gets together with sulfur. Both sodium want to get rid of 1 electron, both sulfur want to gain 1 electron. So it makes sense for these electrons here to move over to sulfur. And this is exactly what they do. And there they are there. So what we've now got is 2 extra electrons on sulphur, and each sodium here has lost an electron to give it a positive charge. And this is called an electron transfer diagram. So let's look at how to write these ionic formula without having to draw the pictures. So sodium has an ion of +1 and sulphide is 2-. Where do we find these? There's 2 places. One, you'll have a valency table or a common ions table, and it'll be listed there for you. The second place to look is on your periodic table. Remember that everything in group 1 will form a +1 ion. Everything in group 6 will form a 2 negative ion because it wants to get its full outer shell. Okay, so the overall charge on a compound must equal 0. So if we have a look at what we've got here, we've got 1 sodium will give us a +1 charge, and 1 sulphide will give us a 2 negative charge. We need to get these negatives and positive charges balanced, and we can only do this by adding more sodiums or more sulphides. If I add another sodium, I will now have a 2 positive charge. So I've got 1, 2 positives, 2 negatives. These balance each other out, so I get an overall charge of 0. My positive charge equals my negative charge, so I require 2 sodiums and 1 sulphide. And that's exactly what I've got here. 2 sodium, 1 sulphide. Let's have a look at using the crossover method. These are the ions here, and I put a 1 here just for simplification purposes. Write down your 2 ions, and then just bring this little number down to the bottom of the sulphide and this little number down to the bottom of the sodium. And that's how you get Na2S1, same as here. It's called the crossover method, so you can use the valency or the charge on the opposing ion and bring that down the bottom. Of course, this doesn't work if the charges are equal on the atoms or ions, then we don't need to worry about it. Okay, another example here, magnesium fluoride. So we've got Mg2 plus, F minus. Overall charge must equal 0. We've got a 2 plus on 1 magnesium, we've got a 1 negative on 1 fluoride. If I add a second fluoride, I'll have 1, 2 negative charge, so my positive charge equals my negative charge, so I get 1 magnesium, Mg1, and 2 fluoride, F with 2, meaning that there's 2 fluoride. Using the crossover method, all I'm doing is bringing the 2 from the magnesium next to the fluoride, and the 1 from the fluoride next to the magnesium. Mg1, F2. Sodium carbonate. This is a bit different now. We're using a polyatomic ion. Whenever you see 2 or more atoms written together like this with a charge, you need to put them in a bracket and treat them as a whole entity. Do not split them up. They stay together. Carbonate is always carbonate. So we've got 1 sodium with a positive charge, and we've got a carbonate that's got a negative charge. How do we get those even? We add a second sodium. We've now got 1, 2 positive charges, which will balance out the 2 negative charge. Positive charge equals negative charge, so we get sodium, there's 1, 2 of them, and carbonate, there's just 1 of them. Using the crossover method, again, write out your formula. And all we're doing here for the number of sodium is we're looking at the charge on the carbonate, and for the sodium here, or for the carbonate, we're looking at the charge on the sodium. So we'll bring the 1 down for the number of carbonate, and we'll bring the 2 down for the number of sodium. Magnesium nitrite, there are our charges. Okay, this is about as tricky as they get, because you've got a +2 and a -3. It's a bit like doing fractions. Now you need to think of something that they both go into. The easiest way to do it is multiply them together, and you'll get 6. So if we add another nitride, we'll get a -6 charge. If we add 2 more magnesium, we will get a +6 charge. +6 minus 6 equals 0, which is what we're looking for. Our positive equals our negative charge. So we get 3 magnesium, Mg3, 1, 2 nitride, N2. Using the crossover method, we write them down again, and we transcribe our little 2 next to our nitride and our 3 next to our magnesium. So now I've got Mg3N2. Ammonium sulphide. Ammonium, it's polyatomic ion again, so make sure you put it in brackets so you don't get confused. Now you're just looking at a 1+ charge there and a 2- charge here. How many ammonium do we need? We're going to need 2 so that we get an overall 2 positive. 1, 2 positive, 2 negative. They balance out. So we get 2 ammonium. That's why we put it in brackets, because we want 2 of these whole particles. They stay together, these ions. 2 ammonium, 1 sulphide. And working out the crossover method, put it in brackets. You won't get confused there. Always keep the polyatomics in brackets. NH4, let's bring our 1 down next to our sulphide and our 2 down next to our nitride.